All right. Hi, everyone. I'm Alex, and today I'm going to talk about microfrontends and module federation, which I know sounds like a lot, but don't worry, we're going to break it down. But before I get into all that, hi, I'm Alex. For those who haven't met me before, I grew up here in Halifax, went to school at Dal, did a comp sci degree, and I've been working as a software developer for just about 7 years. In fact, if any of you worked at Redspace like 5 or 6 years ago, we might have crossed paths because I was there for like a year right out of university, which was fun. But then I spent the last few years working in the UK, and then I moved back just about a year ago, which always seems to be the Halifax story. You know, you move away and maybe you come back. I just came back before I turned 60. And I have I have one cat and 2 photos of one cat named Amelia, and I was told to include those as well because everybody likes cats. We're going to get into a lot of things today, and I don't want anybody to feel too overwhelmed with what we're talking about because it is sort of, it's the next step up. So I want to go over some assumptions that I'm kind of just going to talk about. I might not talk too much about, and it's okay if you don't know these things because I barely know them some days too. One of these is going to be create React app. We're going to be pretty React heavy tonight. You might be thinking, create React app, that's not maintained. You're not supposed to use that. That's okay. We're going to use it anyway because we know what we're doing. We're also going to talk a lot about React itself, naturally. Because we're talking about create React app, we're going to talk about React. Specifically, we're going to talk a lot about React DOM and how rendering works. So again, if these are unfamiliar to you, it's okay. We're going to cover it. We're also going to get into, if that wasn't enough, some advanced React APIs like lazy, error boundaries, suspense. Don't worry, it's okay. We're going to talk about dependencies, which I think you're all probably pretty familiar with, but we'll cover those briefly too. And we're going to talk a lot about bundlers. So if you don't know what bundlers are, that's okay. We're going to talk about those a little bit. But for now, just keep in mind, we're going to be talking a lot about Webpack. We're going to talk a lot about Webpack plugins, and we're going to talk a lot about singletons. So just keep those in your mind. If you have any questions about these and a presentation to cover them, just find me after. We'll talk, and we'll go over anything that wasn't clear. But before we get into the thing, we kind of have to figure out why we care, right? Why are we talking about microfrontends? Why are we talking about module federation? Why is this a thing that we need to worry about? So I've got here our classic client-server relationship. We've got our web app over here on the left. Our users go to that. We're selling shapes. They love our shapes. They go to our app. They buy some shapes. Those shapes talk to our server. And our server comes back and tells us things. And it's going well. They love our shapes, which is great, but it also leads to a bit of a problem. Because our stuff keeps growing. Our server gets huge, massive, and our web app gets huge as well. We're talking, could be minutes for you to build it. So you might be thinking, okay, well, great, we're really successful. Like, why is that a problem? Well, it's a problem for a couple reasons. If any of you have experienced kind of longer development cycles on an app that's been around for maybe something on the order of years, you might get into a point where your builds take minutes. Right? When I started looking at module federation and when my company and my team started looking at it, our builds when you merged to your main branch would be an hour. Now, we were building for 13 different languages in serial at the time, but you would have to wait a long time to see your changes go out. That's because everything is a giant monolith. And because it's a giant monolith, our users might experience longer load times. Remember, it's not just about us, it's about our user experience too. If you've got one giant app and they have to load that whole thing just to see anything on your page, they're not going to be that happy. And this is another issue was if a lot of you worked on like maybe larger teams or larger companies in a monolith, you have a lot of people committing to the same code, deal with a lot of merge conflicts. You're always being like, okay, I'm ready to merge. You hit merge, it's like, nope, can't do it. Somebody committed something over you, and yeah, you need to come back. So maybe we can find a way to fix these. So let's talk about some goals then, right? We have some problems. Let's set some goals to figure out how we might fix those problems. The first is, at the end of the day, we don't want this to be a step backwards. We want it to be a step forwards, which means for our users, we want this to still feel like one application. We don't want anybody to come into our application and be like, okay, great, I'm on page 1, I'm going to load it, awesome. And then you go to page 2, I'm loading it again. Nobody wants to do that. So we want to have one application that feels like one application. We also don't want a performance hit for this. Again, from a user perspective, they don't really care that we're doing something really cool if it means it takes it twice as long for them to load our application. Right? They don't care. They were like, well, just go back to the monolith. That didn't matter to me, it mattered to you. I was like, okay. So we wanted to be performant. And then finally, we're selfish. We want to have a great development experience as well. So when we're doing the work in the day-to-day, we want to feel like we're being productive and that we're not sitting there waiting for the dev server to rebuild the application and get it updated so I can look at my changes, right? So we've solved some of this in the back end before, right? We've got a classic microservices architecture. This is something Kadira was looking at or mentioning before. Right? Instead of a monolith that handles absolutely everything, you break it up. You have microservices that handle the individual domains, in this case, all of our fun, separate little shapes. And we have an entry point that all of our requests go to, and then it just routes them to where they need to go. And this is fantastic because this lets our development teams focus on one or more individual microservices. They only have to care about the domains that they actually work with day to day. No more giant merge conflicts, right? Maybe you have some shared libraries, but no giant merge conflicts. You're not in the same code base with 100, 200, 300 people. And because these microservices are smaller, they're fast to build. And if they're fast to build, they're fast to deploy, which is that feedback loop that we really want. And most importantly, with this kind of architecture, our users, they don't know the difference. They don't really care what we do in the back end anyway, but from their perspective, everything is exactly the same. So what if we took what we learned about microservices and we apply that to our front ends? We say, okay, we've got a giant web app. What happens if we split it up? And I bet we can come up with a very fun term for this even. We can call it microfrontends instead of microservices. And you might hear me say MFEs a lot. That's just microfrontends as an acronym. So let's think about how this might work, right? Before we start actually coding anything, let's think about, okay, well, how are we going to do this? Well, we followed a general pattern that we had with microservices before. And we have an entry point into our application, right? We're going to call this the host, okay? And we want that to be as lean as possible. It's going to be thin as anything because it's going to be responsible for bootstrapping everything else. So if it takes a long time, so does everything else. And it's going to be the entry point into our application, same as our gateway was to our microservices. And we're also going to have a bunch of remotes that we're going to call them, which are all the slices of our application that we've split out into different smaller web apps. And that's where all of our business logic is going to go. We want to have as little as possible in the host. We want to try and stick all that in the remotes. Obviously, only so much we can do, but that's going to be our goal. And you might be thinking, okay, that's cool. We got a plan. How do we get there? Well, I'm going to talk tonight about something called module federation, which is one approach to doing this sort of thing. We're not going to go through all the ins and outs. We're going to do a pretty quick 10-cent tour over the ideas, but they have a wonderful site of documentation, which actually has recently been updated. So if you check that out, they've got some great documentation, all the ins and outs. You can find support for even more tools there. But tonight, we're going to really focus on Webpack module federation. And some of you might be thinking, oh, Webpack, why are we talking about Webpack? That sucks. Well, module federation was first introduced in Webpack 5. So by talking with Webpack, we're kind of starting at the ground floor. We're starting with it where it started. We're going to use a lot of things that, or a lot of concepts that you'll be able to port to other implementations, other bundlers without too much trouble. But we're going to start with the foundation, start where it all started. And because I haven't really focused enough for tonight We're going to specifically look at Webpack module federation in React. If you don't use React in your day-to-day, that's okay. A lot of these concepts are going to be perfectly transferable because at the end of the day, we're talking about module federation. We're talking about federating JavaScript modules. What's in those modules? It doesn't really care too much. It just has to be JavaScript. Cool. All right. So, all right, everybody. See you. Go get building, and we'll meet back here in a week, and you can all show us what you did. We're not going to do that, but we're going to create a host app, and we're going to create 2 remote apps to try and demo how this is going to work, right? And as I'm sure you'd all love to watch me live code, we're not going to do that. I'm going to skip that bit. But if you're curious about any of the code and any of the actual implementation, that's all going to be available at the end. So we will share that out. But let's start. We've got a host app here at the moment. Pretty bare. It's a couple tabs and a spinner because we haven't wired this up yet. We've got our first remote app, which is going to be a list of our products. These are all our wonderful shapes, all sorts of different colors. And then we've got our second remote app, which is our checkout form. So you can actually go and buy our shapes, which is fantastic. So let's go and stitch them all together. We're going to get into quite a lot of different things with configurations. So we're going to start with our remotes, because that's going to be the easiest thing to talk about first. But don't worry about if any of this is, feeling like a lot. It's okay. We're going to go through it line by line. And this is what I mean. We're talking about config. There's a lot here, but we're going to break it down. So the first thing we want to do, right? We've got to name this thing. And you might be thinking, oh, okay, that's easy. But this name is going to be important later because it's what Webpack uses to refer to this in the future. So by using this name and making it unique across all of our microfrontends, we'll be able to uniquely identify this remote. We're also going to set a public path, which for now is going to be localhost because we're doing this all on my laptop. But when you actually deploy this out, this might be the host that you actually find this thing on. So for now, you may want to switch that out for an environment variable or whatever you like. But we're going to stick with localhost for tonight. We're also going to specify a file name. We'll get to why this is important in a minute. But for now, we just want to have an entry point into our remote. This just needs to be something that our host can know about so it can find our all the bits of our remote so that it can load it up. And then we get into, really, the good bit, which is all the things that our app exposes for other apps to use over the network. So right now, we've got one thing that we're exposing, which is our app component, and we're saying we're going to expose that from this path, source, bootstrap, app. Let's see what that looks like. It's like, okay, we're exporting something. This is going to be our remote entry point. So actually, that was a typo. That was meant to say source bootstrap remote, and it said app. I'll have to fix that later. But this is the same thing. This is the same file. The idea being, this is going to be super, super bare bones because this is the eventual component that gets loaded when somebody tries to load our remote over the network. So we want this to be very, very bare bones. It's only going to be our app. And we want to make it a default export. You don't have to, but it makes it easier, so just trust me on that bit. And you'll notice we don't do very much here with it, right? We import it and we export it again. And the reason is, the more you do here in this remote entry point, the less you'll be able to share from your host. So think if we were to wrap that app with, React context providers for theme or React query or whatever. We could do that. It would work just fine. But the problem with doing that is now we stop anything from the host making it to our remote. We get in the way. So we want it to be as bare as possible and just rely on as much of what we get from the host as we can. Let's go back to the config for a moment, because there was one more thing that I didn't show you all. It was sort of the big section at the end. We took a look, we've got a whole section here of all the dependencies that we're sharing, right? And you might be thinking, okay, what does that mean? What do you mean sharing? I thought we were just loading our app over the network. Here's the package JSON for one of our apps. It's pretty thick, especially because I think Create React App just throws everything in dependencies, and it doesn't bother with dev dependencies. But there's a lot here. And some of the big ones are, you've got React. I'm using Material, so you've got that and all of its friends. There's a lot here, and these are chunky dependencies too. These are not small. But the key thing is that each of these dependencies represents someone else's code that we're using. It's not our stuff. And because it's someone else's code, they're all built for anybody. So they're usually quite big. They usually make up the bulk of the bundle that we actually ship to our users, right? Most of the code we send to a user's browser is going to be things like React, like Material. It's not really going to be the code that we write day to day. I mean, maybe it is, but in this scenario, it isn't. So you might be thinking, okay, that's cool, but that means if we have 3 different applications that all use Material, doesn't that mean we're going to be shipping Material to the user's browser 3 times? You're like, yeah, I guess so. But that's where sharing comes in. With the sharing config that we've got here, we're saying that all of the dependencies that this app has, we're going to share them with all of the other apps in this module federation context. So what we're saying here by spreading the dependencies there is we're really just saying share everything. Everything and everything at all. Oh, yes, right. There we go. And by sharing everything, we get a much different result than we would if we were just shipping 3 separate applications. So let's take a look at, here's your brain on module federation, right? On the left-hand side, we've got our sort of standard CRA output, which is really very thin. We've got a main bundle here on the bottom, which is just about everything in our application, right? So we would expect this to be in the order of maybe a couple hundred kilobytes. And then we do have a separate bundle here, which is, we can pretty much just ignore that. That's going to be the Web Vitals package, which comes with the CRA template. But you might be noticing over on the other side, we've got a way different story. We still have a main bundle, right, sitting down there at the bottom, but it's actually going to be super, super thin. And we'll look how thin that is in a moment. But we've got all of these other ones. And you might be thinking, okay, why do we have so many chunks now? Where did those all come from? We had 1, now we have, what is that, 12? Yeah. Where did those all come from? And it's nice because, for the most part, we've got 1 chunk for every dependency that we're shipping to the browser. So every dependency that we were sharing in our Webpack config, we now are sending a separate file to the user's browser when they want to use our application. You might be thinking, okay, well, that's cool. Like, how do you know that? Because that's just a hash and some numbers and chunk.js. There's not a whole lot to go off there. And you're right. There's a way that we can look at this. So I'm using a tool called Source Map Explorer. You're welcome to use sort of similar tools out there. But it's going to give you something that looks kind of like this. Yeah, wow. Roughly each square here, you're not going to be able to read these. You don't have to. But you see all these squares here. Each of these squares is roughly, oh shoot, I completely lost my train of thought. Each square of these is roughly proportionate to the amount of space it takes up in our bundle. So you'll notice here we've got sort of this whole chunk that goes all the way over there and then comes up and comes back. Yeah, that's material. And that's a good 90% of what we're sending to the user. We've got another one down here for some more material. There's a motion down there. How much you want to bet you can find where the code we actually wrote is? No, I'll tell you. It's the box at the very, very bottom right. It's the smallest of all of them, right? Because we didn't write much code. We wrote, a couple screens, and that was it. So what we're looking at here is how module federation is able to help avoid some of that reloading problem. Just think if we've got material already loaded as a chunk from one of our other apps, when we load the next remote, we don't have to download it again because we already have it. So because we have already downloaded that entire chunk, which is 500 kilobytes, we don't have to download it again. And if we're really lucky and our host has a lot of the same dependencies as our remote apps, we only have to download that square over on the right-hand side. And that's where module federation really shines. It takes a massive savings by it allowing us to split up our application into multiple deployable deliveries, but you don't actually have to pay the cost of downloading those dependencies every single time. So that's why sharing is so important. Now, you might have noticed there's two of them here that I didn't talk about. For most of them, we're just saying, give me all the dependencies and share them. But for two of these, we're not. We are saying React and React DOM, these are actually singletons. Remember at the top I said we're going to talk about singletons briefly. Don't have to worry too much about what that means, but the gist is, with React and React DOM, they do a lot of things globally in the user's browser. They set a lot of things up. You have a global React context. That's how it knows, when you're using a hook and all that. There can really only ever be one running in the browser at any one time. If you have more than one, it gets super confused. So by specifying it here as a singleton, we make sure that there's only going to be one running in the browser at any one time. And that's going to make sure that React and React DOM are actually going to work properly. You can omit these, and you can see what happens. You'll get a lot of fun console logs if you try that out. And it'll actually show you a little bit of, it's React being like, you're using a hook, and I don't find a hook context. Are you sure? I was like, I thought I was. So it's a lot of very important 2 lines right there. Okay, let's take a breather. That was a lot. Right, we just talked a lot about sharing, a lot about Webpack config. We're almost there, trust me. Let's set up our hosts. That was all we needed to do for the remotes, by the way. We're done. That's it. But let's talk about our hosts, because there's a couple fun things here, too. So we're back in the config. There's less config here for the host than there was for the remotes. And a lot of it's going to look familiar, right? We've still got the same shared dependencies. That hasn't changed, which is fantastic. But we've got this really fun new section called our remotes, right? So this is our host app. It's loading some remotes. The key thing is that it needs to know where to get them, right? We haven't told it where to go yet. So we've got this fun section here that specifies to the host, hey, here's what's available to you. If you want to go load these, here's where you get them. So let's take a look at those remote URLs for a moment a little closer. So looks kind of strange, but if you remember from what we were doing before, it's actually really familiar because we did all this in the remote config setup, right? So before we had set the name of our remote. Well, that's just up in the URL now. And we'd set our public path. That's just the path that we get the MFE at. And we've set our file name, and that's just the file name that we use. So by looking at the config for our remote, we know what the URL is going to be to actually load it up, which is great, because that means, okay, cool, we know how to build that out. We can do that for as many remotes, as many MFEs as we want. So we've done the config for our host, right? We figured out, okay, cool, this is how it's finding them over the network. Awesome. How do I actually use it? I want to, let's get into the code. Let's do it. I want to get out of Webpack config. It's like, okay, I hear you. It's actually pretty easy now that you've actually done it. So the first thing we're going to do is we're going to import it. Let's see. That import is kind of, there we go. We're actually going to import it. And you'll notice here that the import is just the name of the remote from before, remote app1, / app, which if you remember is the name of the thing that we exposed back in the remote config before, right? So it all ties together. You have to sometimes talk to teams to figure out what's going on, but it all ties together and you can figure all this out just by looking at the configuration. And then we just use it, and it's really that easy. You'll notice we're talking about some more of the advanced React APIs I was talking about here. We've got an error boundary. This is really just catching us to say, hey, we're fetching this remote over the network. It might fail. And if it does, let's just render a shrugging emoji because we don't really know what to do. If it didn't work, it didn't work. I guess refresh the page. We've also got a suspense boundary here where we're going to display a progress indicator. And the CliffsNotes version of this is that suspense is just a way of handling async components, essentially. So our Remote 1 app, if you remember, we're loading that over the network, right? That's not going to be available immediately when we try to render this component here. So we need to do something while it's loading, and we really should display something to the user to say, hey, you're just going to have to wait a second. So that's all we're really doing here. And actually, I forgot to point out, but back up in the import here, you'll notice we're wrapping the import in React Lazy. And that's because we only want to fetch this remote bundle over the network when we need it. If we don't actually want to render this remote, let's not fetch it, because our users don't need that, and they may never go to this page. And because Lazy is making it render, et cetera, that's why we want suspense. And then we just render it, and it's regular React. You're all done, and that's it. So the nice thing there is, I've lost my mouse again. This is a fully fledged React component at this point. It took us a couple steps to get there, but if you remember, that component is loaded over the network from our remote, which uses the expose to go to our remote entry point. And what did our remote entry point export? Just a regular component. So in this example, we're not passing any props. We're not doing anything funny, but we can treat that like a regular React component. We don't have to do anything different. We can pass props. We can do whatever we want. We can do it. We just have to remember it's going to take it a moment to warm up. Okay. Last thing. Promise. It's been a lot. Thank you. You might have remembered we were talking about how the host was going to be responsible for bootstrapping our application in the browser. We didn't actually talk about that much. But that means we need a host entry point. We need something for our browser to actually run so that it can load our application. But there's actually not a whole lot to talk about here, really. This is just the standard CRA index TSX file, but we moved it into our Bootstrap directory and we called it host. We didn't actually change anything. And the reason is we didn't have to. Everything is just React under the hood. The nice thing, though, is because we want our host to be the entry point, doesn't mean that our remotes can't be hosts too. And if you're doing local development, you don't want to have to load like 6 different applications over the network in order to get some work done. You want to just work on the thing you're working on. So we can take this host entry point and we can actually put it in all of our hosts and all of our remotes, and they can all act as hosts if they want to, which means one of our goals was developer experience. You can load just a very thin slice of the app, do your work, commit your changes, and then it'll show up in the whole stitched together thing. There is one important thing that we need to do, though, which is, you remember we were talking about the index file that CRA creates. It needs an entry point. It needs to find something. It doesn't know anything about our Bootstrap files. It just wants to find source index and load it. I'm like, okay, we can do that. But the key thing is that we can't just import the entry point like you might expect, right? You can't just do import bootstrap host. It'll yell at you. And that'll also be a fun thing to find in your console log, because that can also be fun to figure out what's going on. But the key thing is that we need to do it asynchronously, right? We need to import our host asynchronously so that it gives everything time to render. If you remember, back when we were looking at what module federation does to your bundle, remember all those chunks? Well, it doesn't have all those chunks if you just import it. It needs to fetch them. And by doing this, we give it time to actually fetch. So a very key thing that needs to be added, but at the end of the day, you're going to do this once, and you're never going to look at it again. All right. Drum roll. Think we're ready? Awesome. There we go. So there's our host app from before. And then we've got a remote app, and it's all stitched together, which is fantastic. That's exactly what we wanted. And not only does it work, but we get some amazing benefits because of this. This is the whole point why we're using module federation and not iframes, right? We get a lot of benefits. So remember I was talking before about how our remotes, they don't have their own React context. We're not giving them a theme. We're just keeping them super, super lean. Well, the reason for that is that our host app is the one declaring all of the material theming, right? It's the one in charge of the look and feel of our application. Our remote app, it doesn't know anything about that. It just does it. So, and this is going to be easiest to illustrate over, oh, that's the wrong one. I'm clicking the button on my notes. Let's go over to item 2, because it'll be easier to see, because we got a giant blue checkout button there. But you might have noticed over at the top right there, I've got a number of different colors. These are only in the host. There's nothing about this in the remote. But if I change the theme in the host, it changes in the remote, because it's all just React components all the way down. They share the same context. They get the same information. We can do this with anything. So you might be thinking, okay, well, that's really cool, but what if we had like a shared React query context so that all of our remotes could share the same data that we fetched over the network from our servers? That'd be really awesome. What if everything had the same shared React router context, right? Maybe our remotes have some routing, but they don't even have to declare a router. They just be like, yeah, I've got some routes, render them when you're able to. It'll just handle it just fine, because the host will be providing all of those things to all of the remotes. And there's more. Like, you can do anything you can think of. You can do with these, because like I said, at the end of the day, it's really just a React tree. We're loading some components over the network. That's about it. Oh, there we go. Did we meet our goals? We had a bunch of goals at the top. Let's make sure we actually hit them before we sign off for the day. It should feel like one application. I think it does, especially because you can share context between the host and the remotes. Everything just feels like one application. It's super easy. And really, in reality, it is. Like, there is no difference to how this is running in your browser compared to a single monolith application, other than the fact that we load a lot of our JavaScript in chunks as opposed to all in one. But if you had one or you had a bunch, like, it doesn't matter. It all works the same in the browser, which is fantastic. It should feel performant. Well, I think it is. There are some gotchas there, but we do a lot of work to make that performance there. Our initial host app is really thin. It loads some dependencies, and then we don't force our remotes to load those dependencies too. So when you're loading, 6 kilobytes over the network for your remote, it's pretty performant. We're not downloading React. We're not downloading material 3 times. If we were, we'd have to scratch that off. We wouldn't have met that goal. And finally, we didn't get into it too much today, right? But it does have a pretty good development experience, because on your local machine, you're only working on a very small slice of your web application. You're not working on the whole thing. So things like, waiting for your dev server to rebuild because you made a change, that's going to be much faster than if you had a giant application. So I would say we met all of our goals. There are some gotchas. I don't have a whole lot of time to go through all of them today, because I wanted to actually go through the fun bits and not the not fun bits. There are some not fun bits. One of them is caching. So you might remember we had a remote entry file that we named that was always available at a certain URL, right? And our host needs to know that so that it can load our remotes. Well, you might be thinking, okay, the browser is loading that file over the network, and that file never changes. I was like, okay, how does the browser know if that file changes? Because sometimes it changes. We make changes to our remote. Yeah, you got to be really careful, because that file doesn't have a hash. You might have remembered we were looking at all of our chunks. They all had like a hash in them, like a GitHub commit. To differentiate them when they change, that hash will change too. Our remote entry file doesn't do that. So we have to be really careful that our web server is sending all the correct headers to make sure that that doesn't get cached. Because if it does, your changes aren't making it out. You'll be seeing a lot of the old stuff, and if you happen to delete the old chunks, everything's going to go down, and you'll have a fun day trying to switch all that out. There's also deployments, because if you think about it again, Our deployments, we're deploying a whole bunch of chunks all out to our users. They might not be loading all the chunks at the same time. Especially, we didn't get into it today, your remote can have multiple entry points, right? What if they load one entry point and then they come back like half hour later and load the other, and you've deployed in the middle? Your stuff that they might be looking at downloading might be gone because they downloaded the remote entry file half an hour ago, and it's pointing to stuff that doesn't exist anymore. So you have to be very careful when it comes to your deployments. There's a number of ways to mitigate that. You can just make the browser reload everything if it can't find a chunk. That's one approach. The other is just don't delete your chunks when you deploy. That can get messy, but you have to work with what you're given. We also have to worry about dependency clashes. So we talked about how important it was that React and React DOM were singletons so that you had a single context in your application. There's others that you need to do the same thing with. React Router specifically. If you don't have the exact same version of React Router in your host and your remote, it just gives up. It says, sorry, I couldn't find anything. I was looking for this version. I found this version. I don't know. I just white screen, I guess. So you have to be very careful. Dependency management tools can really help with this, but a lot of good end-to-end tests will help this as well, just making sure everything is all coordinated on the way out to production. And then finally, dirty contexts. I'm not talking about React contexts here. I'm talking about your browser context, your JavaScript context. Let's say, for instance, one of your remotes loads a whole bunch of global CSS. As soon as that remote comes in, everybody gets that global CSS, which is a joy. Sometimes that's what you want, because maybe you want your host to be giving global CSS to your entire platform, and you want that common theming. That makes a lot of sense. Sometimes you have global CSS that's for a specific button in one of your remotes, and then you load that remote, and now every button looks like that button, and you spend 2 days trying to figure out why that happened, and it's not fun. Don't use global CSS if you don't need it. But also be wary of this, that it can happen, and keep an eye out, especially the load order of your remotes can make a big difference there. Wow, okay. I did better for time than kind of better for time than I'd planned. But there was so much more we could talk about here. We cut a whole lot of things for time. I say we, I mean me. I cut a whole lot of things for time. I could have gone forever. But we have a number of things. A remote can be a host too, right? We were very flat. We were here's a host, it loads some remotes, and then we're done. But a host can load remotes, which can load remotes, which can load remotes. And because you're all loading into the same context, right, it doesn't worry too much. But it means you can have a lot of flexibility where we have the checkout remote, right? Maybe we don't actually want the host to load the checkout. Maybe we want our pricing page to load the checkout. So we have a bit of a chain there. That's completely fine. All the host config, throw that in the remotes. All the remote config, throw that in the hosts. And they all mesh together, and you're all A-okay. Another thing we didn't get into is we can federate anything, right? It doesn't have to be components. It can be any JS module. So you remember our entry point just did an export default of a thing. That thing can be anything. It can be functions. It can be objects. It can be whatever you like, which means that this can be super powerful when you're talking about, say you want an MFE that is really all your theming config, right? You can do that. You can have an MFE that just exports your theme, and you can pull it in wherever you need. And I think one of my favorite parts of this is that with this technique, you recall we have 3 different applications. Well, they don't all have to be React. There are some gotchas, but for the most part, you can mix React and Vue and Angular and everything all in the same application. Because at the end of the day, we're just loading those JavaScript modules over the network. They're already compiled. They might be a little weirded out if you're loading Angular in a React context, but there's strategies around that. And that's it. Thank you all so much. I've been Alex. I work at Datasite, if any of you would like to talk about that. But for any of the slides or code for tonight, I've got a QR code right there. I hope it's big enough for you to all look at. If it's not, I can blow up the screen a little bit. But you can also find all the details on my website, which is at lockhart.dev. And if you want to get in touch, all of my socials and everything are linked there, so you can find out more. And I I guess, yeah, don't look too close at the code because I did it very quickly. And don't read the commit messages because I messed up a lot. Or do, and we all make mistakes. But thank you all so much.